Hi guys, so today was Google Kickstart round G, my second Google Kickstart, and this was kind of little easy only. I mean, I could have done much better, I'd say, but I was making some silly mistakes, costed me some penalty, and uh, you know, it did not go so well also as I expected. But then let us see some solutions. So the first problem was based on string. So there is a very long problem statement, but essentially what the question is asking is you have to find number of lucky substrings. What is a lucky substring? Any string that starts with kick and ends with start. So we have to count how many such strings are available. Okay. So the approach I used was what I will do is I will take two arrays, okay, to store the index values of starting position of every kick and every start respectively. That means there is one kick over here which is starting at index 0. There is one kick over here starting at index 5. Similarly, one more kick. So I will store the index values and I'll do the same thing for start. Okay. The intention of doing this is I want to know how many start are after a particular kick. That means for this kick, how many start are after this kick? 2. Similarly, for this kick, how many start are after this kick? 2. For this one, 1. So 2 plus 2 plus 1, 5. How am I going to know how many start are after each kick? I can use lower bound for that. So I can show the code now. Okay, so taking the string, I will find all the occurrences of kick and I will store the starting index of each. Excuse me. Similarly, I will do the same thing for start. Okay, I will store both of them in two vectors. And then if v2 dot size is 0, that means there is no start only. I will print 0. Otherwise, I will just be using the lower bound function and I will be calculating how many are there. So answer represents total number of such substrings. Excuse me. So this is how I did the first one. It is basic use of lower bound. Nothing else over here, nothing much to tell about. More like a brute force problem only. Okay. So you can have a look at it once again. This is most important part of the code. And of course, making this vector. So now let us see problem second. Okay, so problem second, there is a square matrix having n rows and columns, and each cell has some number of coins, and we can start from anywhere, I suppose. That's how I solved it though. And you can go in a diagonal fashion only. That is I plus 1, j plus 1, I minus 1, j minus 1. So actually to solve this, I don't know if there is some other method. I just use brute force only. So basically what the question is saying is for example, let us consider this matrix, okay? So in this matrix, if I go along this diagonal, that is 1, 6, 7, I will get 14 coins. So I can go only along the diagonal, that is this 1, 6, 7, 2, 1, 5, 3, 2, 12, like that. I can go only along every diagonal, every small diagonal. Like, I hope you're understanding. So like that, if I can go, how should I go such that I will get maximum coins? So I used brute force only. What I did was I will start I will start checking from first row onwards. I will keep going diagonally down, 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 down. Similarly, I will check from last row. I will go diagonally up, 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 up. In this way, you won't get TLE. So I'll show you my code once again. Sorry, once. Yeah. So here what I will be doing is I will be checking the diagonal in the first row only. I will be checking all the diagonals from starting from the first row in this for loop. And then I will be checking for every diagonal starting from the last row. So if you want me to show it in like a drawing or something, so imagine this is the first row, okay? And this is the last row. What I will be doing is I will be checking like this in this fashion. This is first time I will be going from top to bottom. Next time what I will be doing, I will be going from bottom to top in the diagonal fashion. So in this way you won't get TLE and you have to simply find out the maximum sum. I think there is a smarter method, but I did not do anything. I just submitted this. I will think if there is a smarter method. I don't know yet. You can write in the comments if you have done some other smarter method. I can also learn and everybody can. This was a very brute force problem. I felt second one was easier than first one. In terms of writing code and all. So this was all. Okay. Now see problem three. Problem three, again, I did brute force. I don't know the correct solution, the entire solution. I think we have to use a priority queue over here. Or maybe there is a brute force, like efficient brute force. You don't have to do anything much. I don't know. I was going wrong continuously, but I got some points. I got partial points. And basically, I think everybody would have read the statement. If you want me, like you can change every value. Uh, like if the value is x, you can make it x plus 1, x minus 1, but it will ultimately be between 1 and n only. Okay. So I just use the brute force approach wherein I will compare for every value from 1 to n how many moves are required to make all the elements equal to each I. That means if I have to say that I have to make everything equal to 1, suppose, I will check how many moves are there. Then I will do it for 2, I will do it for 3, so on till n. Then I will just record the minimum. So the very brute force solution only I know. I think you can use priority queue. I will try doing it. So if you want to know for partial points, this is how you do it. Just using brute force only. For every value from 1 to n, I'm calculating. That means for every value from 1 to n, I'm checking how many moves are required to make each value equal to I. I ranges from 1 to n. Each value of the array. Because you have to make all values of array equal. Na? So I will try to make all values of array equal to every I from 1 to n. And I will see which one gives me minimum. So brute force I know. I will try doing the other solution, maybe priority Q1. So this was all about my Google Kickstart. I have to improve, solve harder problems and get better solutions. I have to become faster. Moreover, I should also make very, very less silly mistakes. This time I made some silly mistakes, so I should avoid that. Share this video with your friends if you liked it. Please subscribe to my channel, like the video, and look out for other videos also that I have posted on internship tests and other contests and all that. So please share my videos. It will motivate me and of course subscribe. Thank you very much. Bye.